Hi, Algebra 2. This is Unit 2, Lesson 8, and we're just going to go over some key features of functions. This is a lot of review of what you learned in Algebra 1. So the first question I want to know, looking at this graph right here, is it a function? Well, if it's a function, then the x's don't repeat. And remember, to test for a function, if you're looking at a graph, does it pass the vertical line test? Can I draw any vertical line and they'll only go through that graph once? And the answer is yes. And the reason is passes the vertical line test, x's don't repeat, whatever you prefer. Now, is it a one-to-one function? Now, in a one-to-one function, the y's don't repeat, so it has to pass the horizontal line test. Does this pass a horizontal line test? If I draw a horizontal line, it's going through 2 points. So no, it is not one-to-one. It fails the horizontal line test. My domain are my x's, all right? So looking at my x's, the furthermost left x, there's an arrow at the end of this, so it keeps on going forever, so that's going to be negative infinity. And the furthermost right x, again, there's an arrow, so it's going to be positive infinity. My range are my y's. So the lowermost y value right here is at -2. I am including -2, so I'm going to have brackets around that. And then the highest y, they're arrows. So this is going up and to the right, this is going up and to the left. So my highest most y value is infinity. All right, so this right here is just a review of Algebra 1, some key features of functions. What is a relative min, what is a relative max, and what is an absolute max and an absolute min? Well, a relative min is a turning point on a graph. It changes from decreasing to increasing. So it's a turning point on a graph. Changes from decreasing to increasing. It's like a little valley. So if we're looking at the graph up right here, this point at -1, -2 is a relative min. I'm changing from decreasing. Look how I'm decreasing, and then I go to increasing. It's like a valley. A relative max also is a turning point, but it's where I'm changing from increasing to decreasing. It's like a hill. So think of this as a hill. This is like a little valley. Okay, so relative, whoops, I put that in the wrong spot right here. Let's get rid of that. This right here is a valley. So a relative min might look like this. A relative max might look like this. Changes from increasing to decreasing. Now the absolute max and an absolute min, the absolute max is the largest value reached by a function. It's the highest y. So absolute max is the largest value reached by a function. It's the highest y value. And the absolute min is the smallest value reached by a function. It is my lowest y value. So in the graph that I had up here, I have an absolute min. It also happens to be a relative min, but this point right here is an absolute min. There is no absolute max because it keeps on going. So this is an absolute min. This right here would be an absolute max if I'm looking at that other graph. All right, let's label each of these points as an absolute max or min or a relative max or min. So the absolute max, that's the highest point on the graph. So let's look for the highest point on the graph. Well, the highest point on the graph is right here, up in the upper left. So that is my absolute max. Let's look for my absolute min. Change the color here. So my absolute min is the lowest point on the graph. Well, that's going to be right here. Absolute min. Okay, and then my relative max or min is basically any turning point. So relative max or min is any turning point. So here I have a relative max. Here I have a relative max. Here I have a relative max. Any turning point. And the max is when I go from increasing down to decreasing. Here I have a relative min. And here I have a relative min. And here I have a relative min. Okay, let's turn this over to the next page. We have a graph. We're going to try and answer some questions. All right, function y equals f of x is shown graph to the right. Answer the following questions based on this graph. State the y-intercept of the function. The y-intercept is the point where it crosses the y-axis. So it's a point where it crosses the y-axis. Well, let's see where it crosses the y-axis. Here's my y line right here. And the point where it crosses the y-axis is y equals 2. State the x-intercepts of the function. Well, that's where it crosses the x-axis. Let's find my x-axis is right here. Where is it crossing my x-axis? Right there at x equals 4. And on the left at x equals -6. These are also called the zeros. All right. Over the interval from x is less than 2 and greater than -1. So I'm looking for this interval. Is f of x increasing or decreasing? How can you tell? So let's find that interval. So I'm going from -1, which is right here, all the way up to 2. And I'm increasing. How do I know that I'm increasing? As I move from left to right, the y increases. So it's increasing. As x moves from left to right, it's going higher. It's going up. All right, give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? So f of x is greater than 0. Well, f of x, that's just really my y. When is my y greater than 0? So anything above the x-axis. I'm looking for where y is greater than 0. So let's look right here. So where is y greater than 0? So here's I'm going to make this the same color that I had. Here's my x-axis. It's anything above that line. So my x-intercepts are -6 and 4. So basically, the part where it is the interval where y is greater than 0 is going to be where x is less than 4 and greater than -6. If I want to write it in interval notation, I can write it like this. There are no equal signs. If you're looking at this right here, there's no equal sign, so I'm not including the -6 and I'm not including the 4. Why? Because f of -6 equals 0 and f of 4 equals 0, and I want it to be greater than 0. It's greater than 0. All right. State all the x coordinates of the relative max and relative mins. Label each. All right, so let's find my relative maxes, and I'll put those in a color. Let's see, let's do a blue. So my relative maxes. Here's a relative max. And here's a relative max. It's basically all my turning points. Okay, so my relative max is at x equals -4 and x equals 2. Let's find my relative mins. I'll use this purple color. So my relative min, here's a relative min. Here's a relative min. Oops. Okay, so at x equals -1 and x equals 5. So it's all my turning points. All right, F wants to know what are the absolute max and min values of the function. Where do they occur? Well, let's go back and look at the graph again. So my absolute max, that's the highest y value. My highest y value is right here, the one that I have in blue. So my highest y value is right there. It's 1, 2, 3, 4, 5, 6, 7, 8. So my highest y value is 8. And then my absolute min is my lowest point. My lowest, I'm just looking at this. My lowest y value, which is right there. So this is my absolute min. And this right here is my absolute max. All right, so my absolute max equals 8. It's my highest y value. And my absolute min, oops, is -4. It's my lowest y value. I want to state the domain and range of f of x using interval notation. My domain are my x's, so I'm going to look from left to right, right? So my domain goes left, right. My range are my y's, that goes up, down. So let's peek at the graph. All right, so my furthermost left value, I'm going left, right, my furthermost x value is right here. And that's 1, 2, 3, 4, 5, 6, 7, 8. So it's at -8. And my rightmost value, x value, is right here at 1, 2, 3, 4, 5, 6. So it's basically, whoops, get rid of that, sorry about that. My domain is from -8 to 6, and I am including those points. My range are my y's, that's my up, down. So my highest most y value is right here, because that's my highest one, and my lowest y value is right here. So 1, 2, 3, 4, that's basically my absolute max and my absolute min. So my range is going to be from -4 to 8. And again, it's the same numbers that were over here because it's my absolute max and my absolute min. All right, if a second function, g of x, is defined by the formula, g of x equals 1/2 f of x plus 2, then what is the y-intercept of g? So basically, to find the y-intercept, I'm just going to plug in 0. So to find the y-intercept, plug in 0. All right, so g of 0 equals 1/2 of f of 0 plus 2. So basically I'm doing f of 2. and I'm going to do 1/2 of that. Well, f of 2, if I'm looking at that function right there, f of 2 is 8. And 1/2 of 8 is 4. Okay, so let's just peek up here. F of 2 is 8. Here's 2, and 1, 2, 3, 4, 5, 6, 7, 8. So right here, f of 2 is 8. And then 1/2 of 8 is 4. That's going to be my new y-intercept. Okay. And one more page. Consider the function g of x equals 2 times absolute value of x minus 1 minus 8 defined over the domain for when x is less than or equal to 7 and greater than or equal to -4. So let's sketch a graph of this function. Let's put this in my calculator. Okay, I'm going to put it into y1, and then I'm going to copy down a table. So if you get out a calculator, you can do that. I'm just going to do my table this way because I'm a little short of space. So basically my x's are going to go from -4 to +7. So I'm going to write a little small so that's all fits in. So you're just putting this into your calculator and you're going to go to your table and copy it down. All right, so looking at my calculator, I'm going to go to y equals, and it is 2 times absolute value. So I hit the math key for the absolute value. 2 times absolute value of x minus 1. Then I hit my right arrow to get out of the absolute value, minus 8. Okay, then I'm going to look at my table. So I hit second and graph because the table button's right above there. And then I want all the values from -4 to +7. And I'm just going to copy these. So -4 is 2, -3 is 0, -2 is -2, -1 is -4, 0 is -6, all the way up to 7. 7 is 4. Okay, so you're going to take all of those values and you're going to copy them. So I'm going to go back to my paper. -4 was 2. -3 was 0, -2 is -2, -1 is 4, 0 was -6, 1 is -8, 2 is -6, 3 is -4, 4 is -2, 5 is 0, 6 is 2, and 7 is 4. All right, and they want me to sketch the graph right here. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to start here in the middle at -1, 8, because 2 is 6, 3 is -4, 4 is -2, 5 is 0, 6 is 2, 7 is 4. And then it's just a mirror image on this side. 0 is -6, -4, -2, 0, and 2. So there's my graph. All right. I want to state the domain interval over which this function is decreasing. So I'm just looking at where the function is decreasing. So the domain are my x's. So I'm looking for where it is decreasing. Right here is where it's decreasing. So what are the x values when it's decreasing? The furthermost x value is 1, 2, 3, 4 from -4. And my furthermost x value, only where it's up until where it's decreasing, it is decreasing up until +1. Now you actually have a choice whether you want to include those numbers or not. Either of these answers would be okay. You can either include the -4 and 1 or not include the -4 and 1. Both are okay. Next one, I want to state the zeros. So the zeros of the function, I'm talking about my x-intercepts. So my zeros of my function are here and here. So I'm talking about the zeros, the x-intercepts. x equals -3, x equals 5. Then I want to state the interval over which g of x is less than or equal to 0. So I want to find all the y's that are less than or equal to 0. So basically, anything below the x-axis. All right, so below the x-axis. And they really just have to do with my zeros. I want to include, notice it says less than or equal to 0, so I'm including the numbers this time, not like on the other problem. And I'm going from -3 to 5. Okay, so I'm going from right here, -3 all the way up to 5. So basically it's anything below that x-axis. Evaluate g of 0 by using the algebraic definition of the function. What point does this correspond to on the graph? All right, so g of 0 equals 2 times absolute value. Whoops, let's fix that. 2 times absolute value of 0 minus 1 minus 8. This is 2 times absolute value of -1. Absolute value of -1 is +1. So 2 times 1 minus 8 is -6. Where does this correspond to on the graph? Well, it corresponds to my y-axis right here. 0, 1, 2, 3, 4, 5, 6. So 0, -6 was the point. It corresponds, it's my y-intercept. Are there any relative max or relative mins on the graph? If so, which and what are their coordinates? Well, let's peek at my graph again. The relative max is the highest point, and the relative min, well, it's a turning point, sorry. Relative max would be a turning point where it goes from increasing to decreasing, which there is none, but there is a relative min, and that would be right here. This point right here is a relative min. It goes from decreasing to increasing. So my relative min is at 1, -8. It's where the graph goes from decreasing to increasing. All right, 2 quick definitions. Continuous function and discontinuous function. So continuous function, I can draw without picking up my pencil. There are no breaks, no gaps. What does that look like? Let's get a different color here. It can look something like this. That's a continuous function. A discontinuous function, there are breaks or gaps. What does that look like? I can have something like this. It ends here. Then there's a gap. And then it keeps going. Remember, the open circle is if I'm not including that point. The closed circle would be that I am including that point. But you can see that there's a break there. All right, a continuous function f of x has a domain of -6 to 13 with selected values shown below. The function has exactly 2 zeros and has exactly 2 turning points, one at 3, -4, and one at 9, 3. So these are my turning points. One at -3, at 3, -4, so right there, and one at 9, 3. Those are my turning points. State the interval over which f of x is less than 0. So basically, I'm looking to see where my y is less than 0. Looking for the y is less than 0. And here it is less than 0. Let's maybe highlight it for us. So I'm looking for what f of x or y is less than 0. It's less than 0 right here, here, and here. all the way up to here, but not including the 0 and not including, so less than 0 all the way up to there. So now I'm going to peek at those x values. So basically from -1 to -8. I'm not including the -1 because at -1 it's 0. And I'm not including the 8 because, oh, this should be a positive 8. Sorry about that. I'm not including that because also that is, I'm trying to erase that right there and that's not working. There we go. I'm not including the 8 because, again, at 8 it's 0. And I just want where it is less than 0. All right, state the interval over which f of x is increasing. So it's increasing. Well, let's look at this. So here I'm decreasing because I'm going from 5 to 0. Okay, I'm still decreasing. I'm going to -4. Then, I mean to do that. So here, all the way up to this point, I am decreasing. Now I'm going from -4 to -1. So at this point, I start increasing. So this is sort of my turning point right there. So I'm increasing right here. I'm increasing 0, 3, and then, I'm going to stop increasing because now I'm going to go down. Now I'm going down, so this is another decreasing right here. All right. So I want to know, state the interval over which it's increasing. So it's increasing from 3 to 9. Okay, so here's where my increasing is right in here. All right, but again, I'm not including the 3 and I'm not including the 9 because that's sort of my turning point. All right, and that was lesson 8. So we got one more lesson in this unit.